So, hello everyone. We are here. We are live, and I'm not alone. And actually, I'm standing here in the front of our new building. And we were thinking to make this webinar a little bit more interactive. So, let me first of all add my colleague, Tobias. Tobias, now you're on too.
Good morning, Jörg. Good morning, guys. How are you
Hi,
doing?
Tobias. Doing pretty good. I could know, but I don't remember how many meters are between you and me. The meters between the next one I'm putting into this webinar. Yeah, that's quite some meter, some miles, some kilometer. Hey, Jemson from Singapore. Very good. Very good afternoon.
Yes, this is 3 o'clock at this time.
Yeah. So, yeah, we wanted to surprise you a little bit, Jemson, and to give you, as the pandemic is still on, yeah, we at least wanted to give you a little bit a sneak of what you can expect in our new location here. So, yeah, I'm standing at the front. Let me just show our wonderful flags we have here in the back. Yeah, and Tobias is actually at the back of our production. And yeah, hello and welcome everyone. Hello from Singapore. Hello from Germany. We are, James, how you say that in English? Overwhelmed. Yeah. Wow. We had like 360 people signing up for this webinar. I must admit that really gives us a lot of energy and a lot of power, so that we are on the right track here, and yeah, that we give high quality content, and yeah, we can really share our solution and our knowledge. So welcome, and give me a short time to introduce my colleagues here. Tobias, the key account manager, the product responsible, and yeah, our vice president from Singapore, Jemson. Yeah.
Hello.
Okay. So let me shortly move in. I hope all the connection and everything goes well. Yeah. Today, Jemson is the master of ceremony again. And I think we share some very interesting knowledge, and we can share some very interesting knowledge. But yeah, Jemson, maybe you do a short introduction of the today's topic. I think that yeah, that would be great.
Yeah. Thank you so much. I think, what is the agenda for today? Seems that my PowerPoint is not working.
My one is working, Jemson. My one is working. I know you cannot probably not see it, but or we can take yours, however you like. It's
yeah.
Good. Yeah.
Well, just give me a minute.
You want to use mine? Actually.
Yeah, this is yours.
Yeah, okay, this is mine.
Yeah. Will be great. Can I have the next slides, please?
Yeah, absolutely.
Yeah.
Okay. Yeah.
Well,
here's the agenda overview. Yeah.
Yes. Having this is, I think, this is having the 6th month of webinar. Yeah, this is the last week of the month and the May, where we have done exactly 6 months of webinar, and putting them together on a point of system integration. You see, over here, we wanted to share about, from the manufacturing point of view, we have so much feedback from many of our partners who purchase our equipment, and they do the construction, their own design. And later on, we gather a lot of feedback, some good feedback and some, something that we can improve, such as why, the flow meter gets sticky, and why, the water carried over and resulted corrosion. What happened, when the plant shuts down and then there's a SO2 still reading on the analyzer side, despite they're doing a zeroing, they're doing purging, and after a while, after a couple of hours, they will realize that the SO2, we see another 10 ppm. What is the whole reason? All right, and then some people experiencing low flow. All those things, we want to compress this thing, we wanted to address what really went wrong and how it went wrong right from the beginning.
Yeah.
So therefore, it is important for us that, we want to keep an open-minded. We also realize that lots of very experienced and a guru out in the audience. Therefore, therefore, I'm very nervous.
we should be, Jameson. This keeps the level high, and this keeps the pressure pretty high.
Yeah.
But thank you for doing this introduction. Maybe first of all, I would like, it would be super nice of you if you can shortly, share, say hello to the crowd. I think it's really, we are worldwide. We know that we have visitors for the webinar from all over the world, and at least for us, it gives always a very special feeling to see, hey, hello from wherever you are located and wherever you are watching this. It would just be super nice if you can share this with us. Obviously, you can always also share any comments, any feedback. I think your feedback, and that's the reason we want to thank you. Your feedback and your comments really helped us to improve and to achieve hopefully a good level of what we are doing here. Jameson, I think we have a little bit of surprise for you because as you might be able to see, Tobias is in a different location.
Yeah.
And now we want to check your knowledge, Jameson.
Oh, yeah.
No, I'm kidding.
Okay.
I'm kidding, but no. What we want to do is we want to give you a short overview. Tobias actually is standing in front of a full equipped analyzer house, which is recently finished in our new production. And he will also give us another perspective a little bit later on. But we just wanted to show there's mainly two different applications we always talk about. First application is the emission monitoring system, and the second application is the process analytical system. And as you can see here, this is a nice smaller version, but still with some components of the sample handling system. And okay, James, I was just kidding. You are not going to be asked about checking the PNID and checking if everything's wrong.
Oh my God.
I just wanted to do this a little bit more unpredictable for you guys. So no, okay, good. Okay, we return to the screen, and before James and I hand this over in your hands to share the details of this topic, there is something, and you guys might have seen this in the LinkedIn posting. We are super excited because your attention and your commitment to this webinar made us thinking, okay, what else can we do to make sure that there's really high quality technical information here in this webinar. And Jameson, I think you would agree, from time to time we get, or not from time to time, relatively often, we get questions which are related also to the analyzer, right?
Many times, many times.
Yeah, many times. And I mean, we always indicate here, and we always say it's only if the sample handling system, the probe sampling system, which means our solutions, our components, combined with the analyzer, is in how would you say that, perfect harmony, maybe. Only then we can make sure that the results of the analyzer system is accurate, right?
Absolutely,
Yeah.
absolutely.
So we were thinking, okay, what else can we do here, and what can we do in the future? Because what we don't not want to do is just to repeat ever and ever again. So at the end, you say, okay, this webinar is similar to the previous one. So I'm very happy to announce, and this is the reason why it's probably hard for you to read, what is coming up in the next webinars. We are putting together, I would say, a really nice schedule and a really nice line of next webinars. And in these webinars, we will give the chance also for, I would say, big names. So that means we will have super experts in the field of process analytics, in the field of emission monitoring, and we managed to get some very interesting analyzer OEM who are joining here. I'm super excited to have them here on board. And again, also for them, it's clear that should not be, just a marketing show. We are really going to see what is their solution and what is their thinking of sample handling systems, so that we really have the approach and the possibility to share interesting knowledge to you. That means we will have guys from the analyzer manufacturer here. We will also talk to experts in very special fields. I'm super happy that we will have one webinar about surface treatment, mainly for the heated sample lines, where we managed to get our two partners here on board. And you will have a perfect overview of, okay, what can we do there, and what is in which situation, what will be the right solution to choose. This week I also had a telephone conversation with someone who's very experienced in the field of regulations, so that we can share how in the European Union is the regulations about emission monitoring and emission monitoring systems. So just to give you a short overview, I'm really super excited to use this platform with you, to get some first-hand expert knowledge. Okay, Jemsen, now I stop with doing the advertisement.
Wow, I am too excited to see that, so much things that I can learn the upcoming webinar from all these gas analyzers manufacturer, as well as those very special material, especially when you talk about the surface. Yeah, this is really an engineer that many of us, especially from my side, from Asia, we are very new, and it will be a very enhancing for us.
Yeah.
So let me actually kicks in the word about gas sampling. Today, the webinar is about sample configuring, from configurations as well as system integration. So we all know, we are aware that as far as SAM is concerned, two most important factor for all the end user who wanted it, all right, is the uptime, the availability, you see? And number two is the gas measurement, the reliability, how accurate and how reliable it is. But however, this is where, the big difference between a process sampling system and a emission sampling system. many a times, CEM systems in certain part of the world, they are largely neglected. They are largely neglected because they feel that it is something that they are not able to get the return on investment. Therefore, they goes into, you know, pricing, and then they pick up some of the products that is really, it is not right for such an application. So to address this, we wanted to treat a CEM system will be just as important as a process system, like a quality control, a measurements that we do not want it to be broken down so easily. So the first thing I'd like to say is that.
But James, may I shortly ask, I just know about the European regulation. There's very strict regulation about the uptime of a system. So you're saying in other markets, this is treated and handled a little bit different? Or?
Yeah, in most part of the Asia, there is no such a requirement. In the regulation, they are plainly mentioned about compliance, about the threshold limit. At the most, they will talk about the volumetric measurement, and they never really say that, you know, how much uptime is needed before penalties, you know, kicks in. This is an area whereby it's a loophole for many times the customers are buying systems that is low cost and resulted, I mean, a low price, but resulted a high cost in the later way.
Yeah. This is the dilemma sometimes of the CEM system, right?
Yeah.
Because it's just a cost factor, so to say. That can be. I would agree to this.
Right. So in this webinar, I'm going to put myself in the system integrator. You know, I put myself in their shoe from the point of a system integrator. What are the things that I need to address? Right.
Okay.
Starting from the regulation, the design, the buying, and all the way to do the configuration and the construction. So I know it's just 1 hour, but please bear with me. The biggest question right now I'd like to address is that what is the biggest difference in process sampling system and emission sampling system? You see, a process sampling system first kick off with a very, you know, the sample, normally they are clean, they are pressurized, okay? And therefore, the biggest difference on the emission, the sample is normally are dirty. They consist of dust, they have water, they have, you know, acids, and they are normally is in negative pressure. Therefore, in the design, in the point of design, you cannot use the same the way of thinking of using a process thought and then apply it to the emission, because the emission sampling system has to address one thing, just one thing. If you overlook this one thing, is condensation. If you overlook this, you will see the impact. So what is the impact? The impact, if you do not really address it right from the very beginning, is the physical property change from the gas to water. And
that's James, maybe this is super interesting to see Tobias and to see Tobias' background. Tobias, maybe if you can go a little bit closer even to the sample handling system, which would be a process analytical sample handling. In this case,
confusing to position myself right.
I can clearly see that. No, but it's interesting to see, because here there is not a lot of PTFE tubes. It's more or less it's a lot of stainless steel which is used there, right? And I think this is also interesting to see, because Jemson, you said process analytics is often with a positive pressure, and emission monitoring is with a negative pressure. Means we are sucking more or less, right? Thank you, Tobias. I don't want your arms to die.
So back to condensation, right? Where this is that, you see, to address condensation, we always have to relook ourselves into the construction to address the word dew point, water dew point, and acid dew point. Imagine if you are not able to address the water dew point, all right, and you react with dust, which is present in the stack, what will happen? The water and dust, when they reacted, if it, at a low temperature, it becomes muddy, like a mud. If it is under a very high temperature, it becomes cement, becomes hard cement. Now, on the other hand, we're talking about acid dew point. We have to address acid dew point to prevent acid condensation. Suppose if we have sulfuric acid formed because of SO2 or HCl, what happens is that it becomes corrosive. You do not want your gas analyzer to be corroded, isn't it? Therefore, in order to build a robust system, we have to address this condensation right from the beginning. So this is P&ID diagram. It's a very simplified diagram, but it carries a lot of meanings, right? So
what do you mean, James, by simplified? I see already a lot of symbols which do not look so simplified.
This diagram really takes it really carries a lot of education. You know, if you really allow us to explain this diagram alone, it would take 1 hour. So perhaps we just relook at the from the system point of view. You just push the button on. We're going to address.
You want me to
push? Push it. Just continue. Continue.
You're right.
Just continue.
But James, maybe I think it's good to say, having such a complex. I know that there are more complex P&IDs out there, but having this scheme, what always helps me is really to identify what is the main elements, what is the main components here. So we have the stack, and we would call this the sampling, the primary sampling point. This is the part where we talk about as a product, as a solution, we talk about the gas sampling probes. Then we have the sample gas transport. This is the red line here. And then finally, but Jimson, I think we must admit, this is only for the so-called cold extractive sampling systems. We will then have a cooler. But a conditioning system is, I would say, always needed, right? There's always some kind of flow or filtration which has to be done, right?
Right.
So you would say if someone understands, let's say, this basic layout, that already can help, and then in this basic layout, there's a lot of different solutions or varieties. Is that correct?
That's right. That's right.
Okay.
So from a system integrator point of view, when this drawing is given to 3 different engineers, and 3 different engineers can put the system configurations, everything is correct, they connected correctly. But when you put in the plant, the 3 different systems that place in the plant and the same measuring point, you will realize that one cabinet or one system, they start to require attention after 1 week. The other requires attention 1 month later, and the last one probably maybe 3 months later. The question is why? Why every engineer, they put up the system according to the configuration of this P&ID diagram, but it cannot perform the same at site, even at the same measuring point. Now, the gap is here. It's about really, truly an experience whereby the textbook you cannot find. All right. So in here, we want to tell you about when we select a sample probe, the way to do a connections, where are the cold spots, where many times where we overlook. And this, people know it's a cold spot, but it's how critical that will impact on the maintenance. Next one is that why is that how we position our heated line, all right, and how much the heated line is connected to the gas cooler, how much space between the heated line to the gas cooler, that Teflon tubing, how much is it needed, or we say allowable, before it connects to the gas cooler. Most of the time, system integrator are not aware. They will end up.
But Jameson, tell me from your practical experience, it sounds easy. You say, okay, if there is a cold spot, how do I find the cold spot?
Yeah, I'll say I from just not too long ago, we just found out that the heated sample line, from the very beginning, the heated sample line connecting to the sample probe, that area already caused SO3 formation. If there is a cold spot, that area, how much is the area? That length of, say, 20 centimeter. Sorry, I would say only about 5 centimeter.
Yeah,
so
very small. Yeah.
It's already. And what happened if there's SO2?
Yeah. I got it. Yeah. No, but I think it sometimes in theory it sounds kind of easy. Say, okay, there must be a cold spot, but in practical, and I know that that this is quite difficult to find the cold spot, because, as you said, depending on the configuration, some areas are blessed with hotter ambient temperatures. But when it might be that you start the operation of your sampling system, and let's say in the summertime, and then in the wintertime, you see some problems, right? So okay, that's I understand this issue.
Yeah, and probably later on, I think my colleague Tobias will talk a little bit on the heated line. Yeah, and we also, you see, at the connections between the heated line and the gas cooler. This is another trick. When you buy a heated line, right, from us, for example, if you buy a 30-meter heated line from us, I mean, this is when you receive the 30-meter heated line, you will realize that you ask yourself, why at the end of the heated line there is a protruding of Teflon tubing of 30 centimeter. Why 30 centimeter? Why not 10 centimeter? Why not 1 meter? There is a reason for this 30 centimeter, meaning it is allowable, non-heated before entry into the gas cooler. And this will be addressed by me in the later part of the webinar.
Okay. Thank you for this, Jameson. I will be the very strict timekeeper again. So I make sure we have enough time, and it's already 28 minutes gone. So probes, gas sampling probes. Jameson, you would agree that there's a huge variety of different probes, right?
There are probes that is so-called make in a very, very economical sample probe. Yeah, we also have customers only buy our sample filter, only the filter element, and they construct their own probe.
They try to construct their own probe.
Yeah, they try to construct, and every year they buy hundreds of filter elements just for their own probes. And well, I'm not saying that, but over here, what we want to say from the system integrator point of view, you see, the probe is installed many meters above our head, and nobody want to climb up the stacks. No one, even though there is an elevator that goes up there. The reason is that the probe is up there, and the stack itself is also an electrode. Yeah, and just psychologically, nobody likes to go up. Therefore, when we're selecting a sample probe, it is very, very important that we must ensure that the sample probe is 180 degrees C. Yes, there are many people are saying that they can provide 180 degrees C, but where are the area that makes the difference? It is only the specification that's 180. But you must understand that the heater element, the heater itself, that really on the body that brings up the entire heated filter up to 180 degrees C. So therefore, it is very important for the system integrator to understand that not just 180 degrees C, just pay a little bit more attention on the heater, all right, the construction.
Okay, Jensen, if I understand you right, you are saying it's also probed. I mean, I have a sample here. This is a filter size, which is also available in the market. Maybe I can shortly show here our version from the PSG Plus probe. Let me just move this out, and yeah, I think it's easy to see the difference depending on the sizes and depending on the surface. In this case, the filtration is even from the inside to the outside. So we compare really, yeah, there is a huge difference. But to be frank, this version also works. And depending on the application and yeah, depending on the industry, and maybe also depending on the country where the probe is operated, you say, okay, maybe someone has to climb up to change this filter every week. And as you said, it's not a big issue. I mean, no one wants to do that, but it's also an option. So I'm trying to say, as long as the holding temperature in the probe is high enough, you might choose a probe with a smaller filter, but at the same time, you have to understand that the trade-off you have there is then more maintenance. Is that something you would agree to, Jimson? Or
absolutely, this is where I wanted to stress about the 1-year warranty before we hand over completely. During that 1-year warranty, as a system integrator, we do not want to have unnecessary telephone call to say that, hey, something wrong. Why the flow it becomes so low? You see, so yeah. And the amount of, having said that, the profit margin at the end of the day will start to eat up, right, due to the attention you have to give after sales support. So therefore, it is important that the filter element itself, all right, I highly recommend it to be filtering from outside to inside. This is actually is something that is very important. We have done this webinar before about probes that we are not going to illustrate this again. It has to be, outside to inside. Number two, the big surface area. Just that, we do not need to go up the stack for the entire year. For the entire year. Are you exaggerating? Absolutely not. This is what we have been doing for all this while. Reason? Because all the stack emission, as far as stack emission is concerned, it is always less than 100 milligram per meter cube. And with this large surface area, we have almost zero maintenance for the entire 12 months.
Yeah. Yeah, no, I completely agree, and I understand. Yeah, and maybe it's also worth to mention that we have two versions of the probe. There's a so-called basic probe, and we have the plus probe. And we tried to put together, actually a real expert in this field who has a long experience, helped us to putting this together and to indicate, yeah, what is the maintenance times in each configuration. I mean, this is also something which is important to know, Jemson. First of all, the primary sampling, the probe, if this causes problems and issues, you have to deal with this. If we remember European ID, you have to deal with this afterwards, right?
Mm-hmm.
So in a good solution would be to solve any problems directly at the primary sampling. And at the same time, we have to understand it's not only maintenance, but it is also downtimes. So in the moment when you have to climb up the chimney to change the filter of the probe, your measurement is down, right? And now you say, okay, sometimes the requirements are not so high, but if you have to do this on a regular base, at least when there's countries where there's very strict regulations on the uptimes and definitions on the uptimes, there is not, let's say, a lot of space left for some unforeseen problems, which can always occur, right? So I think this is also something we would like to indicate here. Mm-hmm. So Tobias, before we hand over to you, allow me just shortly, because we are indicating here the different varieties of the probes. And allow me just shortly to focus on one item. I hope I can... as Tobias said, it's not so easy to find. This is just an indication of the back purging. And as we said, this is the PSG Plus version of the probe. So this really helps us to operate for a very long time without doing any service. And what is also significant here to share is the tubing of the back purging, because we in the PSG Plus probe have the biggest tubing, and at the same time, as you can see, also the solenoid valves here for indicating the back purging are quite big. We saw many probes where they use very small solenoid valves for the back purging. Ours are very big. We would love to see them smaller, but the problem is we do not want to limit the outer diameter of the back purging system. So this is just an overview. We do not have enough time. I mean, we had a webinar about gas sampling probes itself, maybe it's just, let me, before we hand over, share this animation here, which we've been recording. So that should simulate the smoke and the dust, and then you see when the PLC here is activating the solenoid valves, you see the back purge, and you see really the efficiency of this back purging. And this should just indicate that there's good solutions out there, not only from us, also our competitors and colleagues have some solutions there. We can really say that our version here is very sufficient. Okay, now, Tobias.
Yes.
Yeah. Oh, it's nice to hear. You are so. We can hear the background noise.
Yeah, that's kind of the problem, because I don't hear the background noise. So if it's getting too loudy or something like that, you have to mute myself.
Depending on what I hear in your background, I hope the colleagues will. I hope the colleagues will not, talk about me and say, "Hey."
Yeah, the good thing, nobody knew that I'm now standing inside the facility. Right around me, everybody is working and everybody is a bit of confused. So that's a good atmosphere. Yeah, it's kind of irritating, but it's good. Yeah.
We take this little risk. Yeah, heated sample line. Sorry, Tobias. Yeah, sure.
Yeah, heated sample lines. I think the most the most important things Jemsen already said. When it comes to CEMs, the temperature is really the point where the most mistakes happen. And those mistakes happen when people choose poor heated sample lines. That means poor insulation material. You sometimes see this on the market that even heater configurations are based on enough power, but the heated sample lines are poor, so are built so poorly that the holding temperature can't kept inside. So that would be one of the typical mistakes. But another mistake is really the installation. And as Jemsen said, and I think 5 centimeters is even too much. I think 3 centimeters of a cold spot, especially on the probe side, especially maybe you showed this to us, your 3 centimeters of a cold spot, and then you transport all your probe through a heated sample line 30 meter to your analyzer cabinet. You dropped once in temperature, you will never get it up back again, and the condensation happens. Your acid dew point is brought too low, and therefore you get the problems. you definitely get the problems. And another thing is, and maybe the guys don't notice, is always share with your manufacturer of choice. Share the informations that are known for the cabinet. That means I've seen this hundreds and hundreds of times that people are putting, for example, a PT100 to 20 centimeters or something like that to the analyzer side. And this is inside of the cabinet where you have, let's say, a warm environment, and you are putting your temperature to 180 degrees for a warm environment, but 10 meters on the chimney or 20 or 30 meter on the chimney, you have other conditions. And therefore, you only have the 180 degree in your cabinet, but not at the sample entry point of your probe where it is located. So always calculate to bring your points of measurement outside of the cabinet, to bring it really to, let's say the coldest or the most failure appointment, and there you have to measure. That is really the point that happens most of the times, I really can say. And installation. If you can really determine the total length, let your manufacturer do the work for you. Most of the time they do it in a quiet environment. They do it with more experience as other guys outside. And if you want to do some confection of heated sample lines, something like this, and imagine you are standing in 20 meter height or something like that, you will see it will not get that accurate. As simple as it is.
But Tobias, I think that's a good point. That's the pro and the cons, let's say, in terms of the opportunity to cut to lengths. To cut the heated sample line to length. I think that's a very, on the one hand, I think it's a super good advantage because you do not have to lay down these loops, which can cause problems as well. But I think at the same time, and I think we got your point, is to say, okay, indicate the manufacturer, say us, okay, which lengths do you need? What length do you need? And you need one side prefabricated, the other side maybe will be manufactured on site. And I think it's also good to say, Tobias, because you and your team invested quite a lot of work into this, that in the confection of the heated line, there's a lot of difference. I mean, there's some heated lines we have where we use the shrinking set. It's probably, I would say,
probably the most easy one. Put it over on top, shrink it down. It's done for, let's say, lower temperatures, something like 80 or so, something like 100 degrees C at holding temperature, and you are pretty safe with that kind of work.
And there are others like the one you shared in the camera, or the one we have here on our picture, the left one, the fixed resistant one. This is more complex, right? So it's just like always, communicate. and this avoids really problems there.
And get in touch with the manufacturer. Sometimes it's simply not possible to do the confection at the manufacturer place, but get in touch with the guys that are producing those heated sample lines. They should advise you what is needed to be done on site. Give them documentation, give them advertisers. For each heating cable, you can do another confection. It sounds absurd, but sometimes it is.
Yeah, but maybe to outline one of the information here and the connection. We talked about the cold spot quite a lot, and I think it's a nice picture where you can see what we do here in order to make sure that there is no cold spot from the sample which comes out from the gas sampling probe and from the connection to the heated sample line, right? Because this is really something, that all of our colleagues make sure, and in our design, we make sure that the heater in the heated sample line, maybe Tobias, you can just show this, that the heater really goes to the top of the heated sample line, and that really avoids the problems here. Sometimes I must admit, we talk about so high sophisticated systems, and then such a small thing like condensation can do so much harm to the entire system, Jemsen. I think that's also interesting to see and to know, right? Because we try to prevent so many things in the beginning, and then you just miss the connection from the probe to the heated sample line, and that can already cause some issues and some problems.
Yes.
Yeah. Okay. Timekeeping. So sorry for that. Okay. The rest of the this is actually the wrong one. But Jemsen, I think you already got it in place to prepare the last slide there. Not the last slide, but the last section. As now we discussed the gas sampling probes. Tobias shared the heated sample lines, and now we are very excited, Jemsen, to hear about
the gas cooler.
The gas cooler. Yeah.
Maybe you can show the video of the entire gas cooler. Yeah.
Hold on. Sure. Let me try to do so.
So many a times, gas cooler, when we talk about, literally, I have seen many system integrator use one gas cooler for one shoe fits all sizes. You see, this is an area whereby it's very dangerous. The reason is that there are so many gas cooler available in the market, right? So in the last webinar, I said that a gas cooler is the heart of a gas sampling or gas handling system. Why do I mean by the heart? You either have a weak heart or you have a strong heart. This is so important because not only the two things that you need to know when you buy a gas cooler, two things. Number one is that you must ensure that the quality of the cooling has a stable output or outlet dew point, meaning that if you have more water than expected, your cooler is able to handle. Number two, the cooler itself must have a big cooling capacity. Meaning it has a strong heart. What do I mean? You see, there are many gas cooler available in the market. Not only that, we talk compressor against compressor, Peltier against Peltier. Let's put it, why is it always good to have the first choice to select a compressor, not a Peltier? Reason is that the cooling capacity of a compressor, all right, is measured in kilojoules per hour is much, much higher than a Peltier. So many people who actually system integrate myself, including myself, is that in the past, when I was just did not realize all this, I look at the diagram by looking at the flow rate. All right, so I thought that, you know, as long as I maintain the flow rate within that within the region, that it works. But it is actually beyond that. It's not so simple. So another area that I want to tell you about during the integration, in the system integration, you must keep at least 10 centimeter space, the head space on all sided, including the bottom. Many people, okay, you know, it is always better to have 20 centimeter on top, the head space. Why? Because of the ventilation. If you realize that the gas cooler itself, they are all has, you know, the ventilation holes on all sides. Even at the bottom, if you
but Jensen, sorry, I think at the bottom, I mean, you can operate the cooler standing on something. This is in our version, it's fine.
Okay, so therefore, if you were to put a cooler, all right, keep some space of 10 centimeter, all right, on all sides. This is something that is highly recommended. Another area earlier I mentioned was that the heated line. When the heated line is a repeat, but it is very important that just before you enter into the gas cooler inlet, all right. So many times I've observed that the system integrator has the heated line ended up only at the entry of the cabinet. Only at the entry of the cabinet. So from the entry of the cabinet on top, all right, and then the whole unheated tubing, the Teflon tubing goes in is as much as 1 meter. So that is a mistake. The reason is that the purpose of the heated line was to bring above the acid dew point and water dew point. And why we invested in such an expensive gas cooler is to able to take the impact of a sudden cooling from very hot to very cool, so that we are able to knock out the water. Now, if you have a long 1 meter non-heated line coming in, the whole temperature, all right, it carries all in. By the time it enters, it's only maybe about only 60 degrees or 45, as close to ambient temperature. So it defeats the purpose. Right, so when you buy the heated line itself, right, particularly from a CEM supplier, you realize that there is always an extra protruding of 20 to 30 centimeter. It deliberately do that is to tell you that in the gas cooler, there are 3 different materials. There's a glass, right? There is a PVDF, or there is a stainless steel. So the PVDF itself, the entry temperature is about 140. A stainless steel can take up to 180. So therefore, the purpose of this 20 centimeter or 30 centimeter is the limit. Is highly recommended, right, to keep a distance of 20 centimeter, maximum 30 centimeter, not up to 1 meter. This is an area. So the next thing is about, I'm not sure if you can see that, you know, the cooler here is showing 3 degrees. It's power up. The peristaltic pump is running. Yeah, many times.
Yeah, maybe Jensen, it's relatively hard to see, okay. But allow us to explain why. Usually, in the cabinet, you would put the cooler at the bottom. And then when you change the perspective a little bit and you look at it, yeah, absolutely. Because usually you would look from this from upstairs to the downstairs. So that's the reason. I think now it's very good to see.
Yeah. We also, you know, on the other hand, is that we also wanted to emphasize that the advantage of a gas conditioner. When the gas cooler is integrated by, you know, a fine filter, a flow meter, perhaps a condensate sensor, it is also something that, you know, for the system integrator to reconsider this its reason is that the amount of distance between one component to another component is limited in a very short distance. It's inside, so it actually avoid physical property changes.
Okay. So, Jemson, sorry again to interrupt here a little bit. The timekeeper is coming in. So very short, because I think that's something which is very useful. You said when you select the cooler, make sure that the cooling capacity is strong enough. Is that right?
That's right. Yeah.
To make, I mean, I know it's the selection is very complex, and we discussed this in our last webinar quite a lot. But by the way, we put a poll in our LinkedIn channel about this, and this was, I really appreciate all of your feedbacks in this field, because that was finally the option which had the most answers. Saying, okay, the constant and low outlet dew point is the most crucial, or the most important characteristic of a sample like theirs. Good. Jemson, we have two questions here in the Q&A, and Tobias, I'm going to unmute you as well. So that, I think that there is an interesting question I would like to share here from Mr. Kumar. What is recommended if heated line is blocked in between inlet and outlet?
Well, depends on the application and depends on the inside material, but I assume I understand your question, and there are some applications where the material itself, the probe itself, is always sticky. So there is no type of heated sample line that you can really negate this effect that it comes to a blockage. And when you have something like this, and you cannot operate with stainless steel tubes, which I assume is your question right now, then I would recommend, if you don't have too much length of a heated sample line, work with a replaceable PTFE tubes. That means your sample probe goes through a 6 millimeter outer diameter PTFE tube, but is inside of a 12 or 10 millimeter PTFE tube. So once it comes to a blockage, which sometimes can't negate it because of different reasons, and then you can replace your inner tube and start the process again.
Yeah,
start the measurement again.
I think that's so that means if we go for stainless steel, we can purge. We can purge
high pressure.
But be careful, guys out there. This can give a hard time to the heating cable. You must make sure that the heating cable allows purging. Our heating cables do, but there's also a limitation of the time. This is important. And maybe this is also something we would recommend if you are, if your, let's say, application might have the problem of getting sticky, take two tubes. You can either take the option from Tobias, tube in tube, replaceable tube, or choose for two PTFE tubes, for example. We very often see this in process analytics in the chemical and petrochemical industry. These guys, they say that the installation of a heated line sometimes is the same cost like the heated sample line itself. And then they say, okay, let's take multiple tubes to have a backup if something happens there.
I like to share my two experience.
Please, Jemson, you have 30 seconds left.
There is a cold spot at the joint between the sample probe and the heated line. This is one of the easiest thing. You know, at the very beginning, the SO3 is formed. The chemical reaction with the dust will block on the very initial part of the inlet of the heated line. Number two, if there is ammonia All right, if there is ammonia presence in the process, that is another possibility. The last possibility is if it is an incinerator. All right, you need to have something, a stripple or scrubble before the heated line. Okay.
Okay, Jemson, thank you so much for adding this. Wow, it's already 1 hour is gone. Crazy how fast the time goes by. We want to thank you. We want to thank all of you, and we want to thank you also for your questions. This is super helpful. As we promised, we will have a session where we talk about more of questions which came up there. The next webinar in 2 weeks, this will be a public holiday in Germany, so there will be kind of a little bit limitation, but we will still have this. And as I said, we are super excited about our upcoming events. We will inform you on our LinkedIn channel, and you will see the schedule also on our website. I'm really looking forward to it, to have all the experts here on our platform. And allow me now to thank you for attending, and allow me to thank my colleagues from Singapore and Tobias from the production. And take good care, and stay safe, everyone. Bye bye.
Take care. Bye bye.
Bye.